overall convolutional neural network pipeline has three main features. I will talk about those. One is the convolution operation that is there. The second is the max pooling operation that is there. And the third is the flattened and the fully connected feed-forward network. Okay, so these are the three main components, and out of these three main components, two components, which is convolution and max pooling, they essentially repeat multiple different times, and you can have multiple different number of layers of convolutions and max pooling inside the convolutional neural network pipeline that we have. So let's talk about what these operations are, these three operations of convolution, max pooling, and the flattened and fully connected at a very high level, so that you can understand what goes inside building the convolutional neural network engine. Okay. So the first main component of any CNN is the convolutional layer, and in convolutional layer what we do is we have several filters that does the convolution operation. So what you see in the figure that we have here is we essentially out of the two main pipeline that we have, we are focusing right now on the convolution, and what it does is we will have specific filters that we will design, and we will basically pass on these filters to the input, which in this case is going to be images. Okay, and we can create multiple different filters, and each of those filters are what? They are essentially different small scale features that we want to identify in the images, and then we will scan them through, and we will move those filters along the images, and we will try to sum up that information in what is known as the output. So the convolution layer will have essentially input, which is image, then you have a filter, and once you apply the filter, moving filter on the inputs, you will get an output, and then we basically do the processing on this output, and that's what is done in essentially the convolution layer that we have. So the main operation, the convolution operation, could be understood using this illustration that we have here. So for example, let's say, and this is just a simplified illustration, for example, if we have 6x6 image, which is represented by this is black and white, represented by 0 and 1 features that we have, and let's say if we have two different filters, filter 1, which is also represented by some numerical values like 1, -1, and filter 2, some numerical values by 1, -1, and you can see that this filters 1 and filter 2 entries are different, and that's why they are different filters. So when we do these convolution operators, what we are interested in learning the network parameters, which basically helps us in identifying the different things that are there in the images that is there. So again, each of these filters that we have, they help us in detecting a small pattern. For example, these patterns might be headlight, car tires, or the rear view mirrors in a given car image that we have. Okay. So again, how does this operation work? So let's go through this operation. What you do is, first of all, you will take the filter and you will overlap that filter on, let's say from the top left, right? So you take this filter and you basically overlap this filter in the same number of pixel regions. So this filter is 3x3. So what you do, you overlap by 3x3 on the original image, and then you do the dot product of all the elements. So for example, you have 1 here and you have 1 here. The dot product of 1 and 1 will be 1. You have 1 here, dot product of that will be 1, and 1 here, and that is overlapping, and that dot product with this is going to be 1. So there will be 3, 1, and all the remaining entries are 0. So when they multiply with the remaining entries that you have here, that is going to be equal to 0. So essentially the dot product is going to be 1 plus 1 plus 1, and you will essentially get a 3 out. Okay, and so this is the convolution operation where we take the filter, we superimpose it on the image, okay, and then we get a dot product of the elements that after the superimposition, and whatever that value, we store that value. So this will be 3. Now after that, what we do is we move the filter by a given defined stride. So what we will do is we will move the filter one column towards the right. Now, so in this location, this is the overlap of the filter with the overall image. So we can see here we have this as the overlap, and now in this case you will see that the filter, the number entries of 1 are different than what we have in the previous case. So if you take the dot product of the superimposed filter at this location right, which is highlighted by the yellow region that we have, in that case, the overall dot product will come out to be -1. Okay, so we keep storing, so we keep moving, and we keep, essentially storing those values. Now, this parameter stride is also a parameter of convolutional neural networks. So in the previous example that we are talking about, the stride value was set to 1. So and what 1 means is like we move one column towards right. But we can change the number of columns that we can move, and we can set that to be equal to 2 or 3. So when we are doing 2, right, again, this overlap with this filter is going to be 1, but when we are doing stride 2, rather than moving one location, what we do from this original location, previously we moved here, but now we are moving 2 columns on the right hand side that we have. So this stride has specific meaning, and then in that case, the new red overlap area is going to be this, and in that case, the output after the dot product with the overlap of the filter and the image that you have is going to be -3. Okay, now if you look into this, what we have done, when we are talking about stride from 1 to 2, essentially this will also reduce the overall number of parameters that we need to learn during the training process.